All right, I think it's recording. All right, um, welcome. This is the first episode of Having Conversations in Public. My name is Vishal Bakshi, and yeah, this series of videos is uh, an opportunity for me to explore some things either on my own or hopefully in the future to have some guests to come have conversations in public with. Um, I didn't want to install anything new for video screen recording type of software. So I'm just going to use QuickTime and I'm going to use a Zoom meeting video and I'm going to share my screen as if we're on a Zoom call, which we all are all the time nowadays. So today's topic is going to be focusing on this particular type of um, sort of data problem that I've been working on. And um, I'll just kind of set the stage by looking at the objective of the problem, as well as talking about some of the resources and tools that I'm using. So in the description, video description below, I have a link to the Google Colab, which has a notebook with everything that I'm going to run through today. I also have that on a screen over here, so I'm going to be referencing that um, so I don't, make too many mistakes. If I do make some mistakes, or if you see something that's not correct, or if you think there's some feedback you have, please comment below. So I'm going to start by showing you the random data, some pseudo random data that I've created to represent what is the real life problem that it is that I'm trying to solve. And imagine that we have these multiple CSVs. Here I've called them dataset 1, dataset 2, and dataset 3. And each of these CSVs have the school name that a student is located in, student ID of each student, their gender, and date of birth. Dataset 2 has the same 4 items, but it also has federal program code. So it indicates, and these are just made up values that this student here um, qualifies for federal program 100, and this student also qualifies for 105. And dataset 3 is looking at the same 4 kind of demographic values, demographic fields, and then it's also looking at a state program code. So I think I generated it from 30 to 45. So there's 16 different codes, state codes. There's 15 different federal codes. There's 5 different schools, A, B, C, D, E, and there's male, female, and non-binary as our genders. And what the objective is I want to create one primary list that shows all the different enrollments for each student. So, for example, if you look in dataset 2, student, what is this? 1,000,001 was enrolled at school A, and during that time they had a federal program code of 100. At school B, however, they also had a federal program code of 105. So that's not necessarily captured here. In dataset 1, I have that student's enrollment at school C. So this student has moved from school A, B to C. And some of the data is captured in one file, some of the data is captured in the other file. Um, and this file does not have that student listed in it at all. So there's no state program codes that the student has. So this is a common situation where you'll have multiple files with multiple school names and student IDs that you're looking at, with different data associated with it. And some files may not have all the schools that a student enrolled in. Some files may not have all the students in them. So it's kind of, I'm trying to combine these three separate data sources into one list that shows who are all the students and what are all the schools that they were enrolled in. So I decided to call that merging unique values, or merging lookup values. So the first thing I'm going to do is I'm going to get the data, and actually the first thing I'm going to do is I actually didn't end up using, yeah. So I'm going to import all of my libraries or packages that I'm going to use. And then what I did was I saved each of these data sets as a CSV file, and then I stored them in Google Drive, got their share link, and then I used this site, rawdownload.now.sh, and here I can paste that share link from Google Drive and convert it to a download file link. So the difference is that it changes part of the URL so that when that URL is accessed, it automatically triggers the download instead of going to the Google Drive itself and seeing the shared document. So I'm just going to grab those from here. So these are the three URLs that I have, and you can access them too. And then I'm going to create an array of data frames that I'm going to load this data into. And then I'm going to load this data in. So for each of these URLs, I'm going to get the data, and then from the response, so this will return a response. This will return a response, and then I want to get the content from that. And then I'm going to read in that CSV file, and I'm going to stream it in using IO string IO data decode UTF-8. So what this is going to do is that this is going to take this content and load it into a data frame. And then I'm going to push that into my array, or my list of data frames. So if I look at DFs, I should see the three CSVs that I showed earlier, one with just demographics information, one with demographics and federal program code information, and the last one with demographics and state program code information. Okay, and then what I'm going to do is add a lookup value to each of these. So what I'm going to do is I'm going to add a column to my data frame that's called lookup value, which is going to be the combination of school name, then a dash, the student ID, and I'm going to make sure that that is concatenated as a string, not as a number. So I don't want it to include a decimal place, which I've noticed sometimes happens when you have a numeric value. So I use as type as string to force it as a string. If this doesn't work, sometimes I also just do integer if it's indeed an integer value like an ID, and it seems to work. And then I also convert that to a string. And then I'm going to take each one of these or each one of these data frames in the list, and I'm going to save them separately, assigning them their own variable. And I'm going to take a look at this data, make sure it looks what I expect it to look like. So here's demo DF, which is this the same as this dataset 1 here, and it has school name, student ID, gender, date of birth, and then it has this lookup value. Here's the federal program data frame, same 5 values, and then our fields, and then the federal program code is unique to just that data frame. And then my last one is state DF, and it has similar data, except it has the state program code. And this lookup value is going to be what I'm focusing on, because a student ID alone is not enough to tell me where the student's enrolled. I need to know which school they're enrolled in as well, and that may vary across the 3 different data sources. So I'm basically going to be comparing and trying to get the unique but comprehensive list of lookup values, which is why I call this actually I'm going to call this merging unique lookup values, since that's what I'm doing. Okay, so there's kind of 2 scenarios that I'm looking at here. One is that student IDs are present in one data frame or one data source, but are not present in the other. And then the second one is that a lookup value is present in one data frame, but is not present in the others. So I think those are, in plain English, are understandable. But I want to show that through Pandas and see, how can I visualize this difference of values between 2 data frames, whether it's a student ID or whether it's a lookup value. So what I'm going to do first is I'm going to just isolate the student ID into its own data frame. And I'm going to do that by using the .loc method or property, which basically says I'm going to take all the rows and just the student ID column. And then I'm going to do that for my fed data frame. And then I'm also going to do that for the state data frame. And then I'm going to put them together, and I'm going to say it's called students DFs, demo students, fed students, and state students. Okay, so if I look at students DFs, it's basically just data frames with one column, being the student ID. Okay. All right, so the first kind of method that I'm going to use is this merge method for data frames. So I'm going to start by looking at the difference between the demographics data that came from demo DF, and then I'm going to look at the federal students data, which came from the Fed DF. So they both came from different sources, and I want to see what are the differences in student IDs between those two. So I'm going to merge my Fed students data frame with my demo students data frame, and it's going to be outer, so it includes keys from or indexes from both. And then I'm also going to set this indicator flag to true, and we'll see that in a second on what that does. I'm going to do the same thing between demo and state, and then same thing between state and fed. And to show you the visualization of, are there student IDs in one data frame that are not in the other, I'm going to query this, and I'll show you why I'm querying this as such. And just take a look at that first. Okay, so if I look at this demo fed diff data frame, it has the student ID, and then it has this underscore merge column. This underscore merge column is a result of indicator equaling true. So I set indicator to true, which means that this merge column was added. And this merge column has three values. It has left only, right only, or both. Left only means basically that it was in the demo students in this case. Right only would mean that it's inside Fed students. Both means that it's the student ID is inside both data frames. So what I'm doing here is I'm querying um, this difference data frame for those values where this underscore merge column is not equal to both. So I'm basically saying, show me student IDs that are not included in both of these data frames. And it turns out that there's 5 students who were in this demographics data frame, but who are not in the federal program data frame. And just for completeness, I'm going to show the same between demo and state. So there's 1, 2, 3, 4, 5 students here. A few different ones than before that are inside the demographics, but not in the state. And then finally, I have my, let me just paste this and change this. I have my difference between the state and the federal programs. So there's 5 students who have state programs because they're left only that were not included in the federal programs, which was the right data frame in this merge. So in so many words or in so many lines of code, what this is validating is that there are student IDs in some data frames or in some CSVs that are not in the other ones. So I guess I'm kind of just setting the stage for my motivation for combining and finding these unique values. But that's just one layer of it because similar to the student ID, I can also have this situation occur in my lookup values because I can have students enrolling at different schools. Before I do that, though, what I want to do is I want to get the total list of unique student IDs. That's something that you can imagine is potentially useful in some process of analyzing this data. So what I'm going to do is I'm basically going to merge each of these data frames with each other. So I'm merging demo with fed, and then I'm merging that data frame with state students. And in each case, I'm doing outer. So if there's any values that are not in one of the existing data frames, it's including those as well. And then I just want to show you what the different values are here, or a different number of values are for each of these data frames. Okay. So when I look at all students, there's 119 student IDs, whereas the demographics has 100, federal data had 64, state data had 63. So combining all the unique values, there's 119 students that are unique. One way to kind of test this is merging my all students with each one of the original sets of student IDs. And so what I'm going to do here is I'm going to merge this here, set indicator to true, and then I'm going to use that query, a similar query from before, where I'm going to say, show me values show me the values that are inside demographic students but are not in my all students. So if this returns values, then this would show any students that I missed from my demographics DataFrames. I forgot a single quote. And this list is, or this data frame is empty, which is great. Or this query has no results, which is exactly what we're doing. We're just testing to see if I indeed captured all of my student IDs, and I'm doing that by comparing it to my existing 3 different sets of student IDs. So at this point, I feel confident that this all students data frame has all of my student IDs. And here's an example of the first 5. So I'm going to do the same thing here. I'm just going to now apply this to the lookup values. So I was able to get a unique list of all the students, but now I want to get a unique list of all the lookup values. So this is going to be very similar. So it's really just a matter of changing a few things in the code before. So instead of pulling out student ID, I'm pulling out lookup value. And I'm going to do the same thing for fed and state. And then I'm going to put them all into a list. Okay. And then I'm going to do the same process of identifying what are the differences between each of these data frames. So between the demographics and federal state lookups, or sorry, federal lookup values, what are the differences? And so here I'm again using the merge. I'm using outer. And then I'm saying indicator equals true. And then I'm going to do the same thing between my demo and state. And I'm going to do the same thing between state and fed. So again, this is just to visualize my claim that there are some combinations of school and student ID which are unique to one or more of these data frames. And another way to say that, I guess, in just plain English or in the real world, is that some of the data was recorded at the school, at the student's next enrollment. So their demographic data might have been saved at school A, but then the federal program didn't start until they enrolled at school B, and maybe a state program didn't start until they enrolled at school C. So between the demographics and federal program, there are 5. Actually, this is just the head, but there are, here's an example of some of the lookup values that are only inside the demographics, which is another way to say that it doesn't mean that this student was not inside the federal program's data set. It's just that this student was enrolled at school C only in the demographics data frame or data set. And then I'm going to do the same thing here. I'm going to look at my demo state. So these are students who are, in this case, only included in the left in the demographics. And then finally, I'm going to have my state fed difference. Okay, so again, I'm going to gather all of these lookups into one data frame, and I'm going to do this by merging the demo with the feds, and then the result of that, I'm going to merge with my state. So I'm reassigning these back to all lookups because I sort of want to have a cumulative data frame as a result. And then finally, to look at this another way is to look at it as the length of each data frame and see the differences in between those. Okay, So there's 160 total lookups. 100 of those were captured in the demographics data. 64 of those were in the Fed lookups. 63 were in the state lookups. Okay. And I think that matches what I had done earlier. So what I want to do is I want to capture unique values, and I want to do that in two ways. One of them is going to be, I guess, slower, and it's going to be probably not the ideal if this is your only goal to capture unique values, but it also provides a lot more insight between the differences between each of the data frames. And then what I'm going to do after that is going to be a much faster approach of capturing all these unique lookup values. So this first one is an approach using sets. So I'm going to start by defining a data frame called all lookups, which is different than what I've done before. And it's going to have the following columns. Ooh. All right. What's going on here? There's always something that pops up when I do a video. Okay, columns. All right, let's just throw them in here. So I have lookup value, which I want, and then I want to get the school name. I want to get student ID, and then gender and DOB. So the four demographic values plus the lookup value, which is really just a tool right now to capture all these other values. So if I look at all lookups, right now it should just be an empty data frame. Perfect. Okay. Now, what I'm going to do here is I'm going to create a set of the lookup values inside my demographics data frame. And then I want to look at the length of that lookup diff. So what this is doing is it's taking this column, it's turning it into a Python set, which is just a built-in data structure. And I see here that there's 100 lookup values. The next thing I'm going to do is I'm going to say, show me which of these lookup values is inside lookup diff. So this is trivial at this point because I made lookup diff from the set of lookup values in demo df, and then I'm comparing demo df lookup values to lookup diff. But it's the nice thing about it being trivial is that it's kind of easy to validate. So what isIn is doing is it's returning essentially the keys or the indexes for which this statement is basically true. So it's saying 100 of these lookup values are in lookup diff, which makes sense because that's what we set it to earlier. So what I'll do here next is I'm going to create a data frame from lookup diff, and I'm going to pull just my lookup value. And then what I'm going to do is I'm going to append that to my blank all lookups data frame. So what this is doing basically, it's saying that the values that are captured here, it's creating that. The indexes that are captured there are I'm pulling those indexes from demo df, turning that into a data frame, and then just pulling the lookup value. This should be a lowercase lookup value column. And then I'm appending that to all lookups. And so if I look at the length of all lookups, it should be 100. And it's 1, which is interesting. Oh, I know why, because I forgot the ignore index equals true. And let's see, I might have to start this over from here. Let's just start this over from here. And let me check my cheat sheet. Okay. What am I doing here? Lookups. Let's see what all lookups looks like. Okay. Well, let me just go here. Cool. We get to troubleshoot live. I mean, this is not live, but I will probably edit this part out. But let's see. Lookup diff pd.dataframe. So I create a data frame. All lookups. I'm appending that. That looks good. Took the set. Lookup difference. Ah. Oh. I forgot a very important step. This is why this doesn't make any sense. So some of you might have been looking at this like, what is he doing? I forgot a key step. Okay, good. So I think this is why. I'm not sure if this is why the issue. I was getting only one record or one row in the all lookups, but I forgot a key step, so this is good regardless. Okay, so the lookup diff is taking the lookup values from the demographics and making a set. And then what I want to do is I want to find the difference between the lookup diff and all lookups. And keep in mind that I'm essentially, the final goal is to do this for all of the data frames. So right now it's, again, trivial, but I'm going to be repeating this process later on. So what I'm saying here is that it's looking at these indexes of lookup diff, or these lookup values, and let me just actually show what this looks like. So it's a set, so it's basically just a collection of these values of lookups. So it's taking that lookup diff and it's finding the difference between that list and all lookups lookup values. So all lookups lookup values right now has nothing. So lookup diff should be 100 at this point, which it is. Thank goodness. Now, the next thing I'm going to do is, I'm going to check to see if, which one of these lookup diff values is in demo df. And they should be all of them. Okay, good. All right, and then finally, somehow I'm not very confident that this is going to work, and it didn't. Ah, I see what I did. There we go. It's the parentheses. So what was happening was I was taking the data frame of lookup diff, which is not structured, or sorry, demo df lookup diff, which is not structured in the way I want it to. I actually wanted to take the data frame of this entire chunk. So I'm not actually sure what the difference is. So I want to see what that looks like. Okay, so it looks like it is just not happy with this. But let me actually start from here and see if it does it. Okay, good. Right. So this is not really what I wanted to do. What I wanted to do is I wanted to make a data frame just from the lookup value column. So what I'm going to do here is if I add this piece of code here, yeah, there we go. All right, this is good. So this should now work. And we indeed have 100. So I'm just going to do the head. Cool. So right now I have lookup values, but I don't have any other fields, which is fine. Just focus on lookup values now. Okay, so I'm going to run through this for each one of my 3 data frames. Well, really 2, because I already went through the demographics one. So the process is going to be as follows. Creating a set from the series of lookup values, and then finding the difference between that set and the lookup values that are inside my kind of final primary list or main list, which is all lookups. And because I'm going to be appending, I don't want to overlap or I don't want to be redundant. So I only want to select those values, those values in my fed.df that are in this difference, this set of difference indexes that are different. So I create the set of lookup values from the federal data frame. I ask, I ask Python to give, or Pandas to give me, actually Python, because it's the set is or difference is a method on a set. To give me the difference between federal data frame lookups and all lookups that right now contain just the demographic data frame lookups. And then this is going to be a list or a collection of indexes And then I actually think if I hover on it, right now it's a data frame because of earlier. And then I'm going to say only give me those values or those rows from a federal data frame that are different than the ones that are already in all lookups, so that I don't have duplicates. And then I'm going to create my data frame, prepare it to be appended. So this is going to take that list of lookup differences, and this time I'm going to put this LOC call inside the parentheses. And then I'm going to append those onto my data frame. And I got to ignore index. All right, so this should update it to 155. That's what I got when I ran it the first time. Cool. So what that means is that there are 55 lookup values that were in the federal data frame, different from the lookup values that were already inside my all lookups. And then I'm going to run this again. This is the last data frame that I need to run this for is the state data frame. And so I'm going to change all my feds to states. And this should be 159 and 159. Cool. So there was 4 that were not inside the state, that were not inside federal or demographic, that were inside state. So even though I think this is done here, I want to kind of wrap these lines of code in a function, because as you can see, I'm basically running this 3 times. So ideally, I would just make a function out of it, which I'll do this here. So this function will take as its inputs the data frame that I want to append, or from which I want to append unique values, and then the target data frame that I want. So let me just call this source df and target df. And my lookup difference starts by looking at the source dfs, or gathering the source df's lookup values into a set, finding the difference, and I guess one thing I could do is I could say pass the column as a parameter. So, if there was another column name instead of lookup value that I wanted to do this for, that I could still use this for. And then I'll finally do this last couple lines. So I turn it into a set, find the difference between the source and the target, and then get from the source only those that are not in the target. Convert those into a data frame. And then return the target df append. So this is going to return a new data frame that I'm going to have to assign back to the original, because it's not happening in place. Okay, so now I'm going to just basically take these, 7 or 8 or whatever boxes or cells of code, and see if I can't just put them into one. So I'm going to take my definition, my initial definition of all lookups, and reinitialize that. And then I'm going to iterate through my list of data frames. And then I'm going to say get lookup values. My source DF is DF. The target DF is all lookups. And then the column is lookup value. I actually haven't tried this with the column parameter, so we'll see if that works. It's not in the other one, in the kind of source file that I already made. But this should be 159. Cool. So one way to also kind of look at this is that this still doesn't, or one important thing to look at is that this still doesn't have all unique values. It may have duplicates. Because I may have duplicates inside of the federal data frame, even if I, made sure not to get duplicates by capturing only the difference between the next data frame and what was already what I had already accumulated. So what I'm going to do here is I'm going to drop duplicates, and I'm going to drop duplicates for lookup value. And then this should be 151. Cool. So in all, there are 151 unique school name and student ID combinations. So one way to say this is that there are 151 unique enrollments that we're looking at. Um, so that's one way of doing it. It's granular, so you can see a lot of in between differences for the different data frames. But a quicker way to do this is to use drop duplicates from the start. And I'm going to do that next. So I'm going to take I'm pretty much going to copy this code down here. And instead of using get lookup values, what I'm going to do is I'm going to append a data frame that has all the values that I want, which is lookup value, school name, student ID, and then gender, and then date of birth. And I'm going to make sure that ignore index equals true. And then I'm going to also, because I still need to remove duplicates that were inside of each individual data frame that would have been appended to this all lookups main data frame. Cool. So this, what it's doing is basically it's pulling the 4 common fields that were inside all of these CSVs. So if I look at my original data frames, I had school name, student ID, gender, and date of birth. Those were all common across these 3 data frames. Federal program code, state program code were unique to the federal data frame and the state data frame, but they also had this basic demographic information. And right now I'm just trying to pull really the lookup values, but here doing it this way, I can also just pull those other columns as well. And so this should also give me 151. And then if I look at all lookups and just the head, cool. So here I have the lookup value, school name, student ID. So this is, 1, 2, 3, 4, 5 lines of code, and it accomplishes the same thing that, this with about, probably like 15, 20 lines of code did. And it gets me what I wanted plus some additional values. So I guess it depends what the goal is. If I want to capture individual differences between data frames, then I think I would do what I did previously. But if my goal is just to get a unique set of lookup values across multiple data frames, then this is much easier. It's much quicker too. Um, and then yeah, I have some notes on validating the data, and yeah, I think I want to go through that as well. Um, so I guess what I want to validate is that did I capture students that were enrolled at multiple schools? Um, and let me make sure. Okay, all right. I think I remember what I was trying to do here. Okay, so I'm going to look at how many duplicates did I have in my data frames. And so one way to do that is to do this, which is um, do a group by and um, group by student ID in this case for my federal DF. Actually, I'm going to do, yeah, I'm going to do this. And then I'm going to query that result or that resulting data frame. Let's see what happened here. Okay, cool. I'm going to query that resulting data frame for school names that were greater than 1. So I had 1, 2, 3, 4, 5, 6 students here that had multiple enrollments in that file. I can do the same thing for state, and I think in this case, yeah, there were no duplicates there. And then I can do the same thing for my original demographics, and I also think there were no duplicates there. Yeah. And then if I look at my all lookups, I'm going to actually run the same query on there, where I'm going to group by student ID, and then I'm going to count, or I'm going to query where the count of school name was greater than 1. And here you'll see a lot more students that had multiple enrollments. So how does that make sense? Why is it that I only saw 1, 2, 3, 4, 5, 6 students in my federal data who had multiple enrollments, whereas here, if I look at the length of this data frame, I'll see 41 students. Where are all these other duplicates coming from? And or actually, I shouldn't say duplicates. Where are all these multiple enrollments coming from? Because I only see 6 students here with multiple enrollments, but there's 41 students in the full data set with multiple enrollments. And the answer is that there are multiple enrollments across the data files that we don't see. So I looked at multiple enrollments within a data file or within a data frame, but I didn't, I'm not showing, this doesn't show how many students had school A in the federal data set, but school B as their enrollment in the state data set, or school C in the demographic data set. So this is just to show that there may be some hidden sort of relations between different data files that um, I didn't even think of, necessarily to begin with, where um, I have, 35 more students that are experiencing enrollments in different schools across, but are only recorded in one of the data files and not in all three. Whereas these 6 students, their multiple enrollments were recorded in a single data file. Um, and even here, I think it's important to note that this number of this school name here is not necessarily indicating multiple enrollments. I could have a student who had 3 federal programs at the same school, and so they would have 3 records. So if I looked at lookup value, I think that should probably 1, 2, 3, 4, 5, 6, 7. Yeah, even here, I don't think it's definitive that um, multiple school names means that they were different, because again, I could have just 2 different federal programs at this particular school. Something that is interesting between these 2 data frames that we looked at. So if I go back and if I do this count by student ID alone, I'll see that this student had 3 records, whereas this student at school B only has 2. So that's one way to kind of see that there were that student 1,000,001 had 2 records associated to one school, but 1 record associated to another school, and I can validate that here. So if I just look at student ID equals 1, yeah, so there were 2 programs, 105 and 100, at school B, and 1 program which was 100 at school A. And all in all, there were 41 scenarios basically where a student had multiple enrollments. Okay, so that's pretty much it. I've added, this. Let me show you what I've posted in the description. This has a lot more explanatory text, which kind of shows the reasoning of why I did it. It might be a little more intuitive when you read it through text. I find myself being able to articulate my thoughts better in writing than speaking, which is why this is also good practice. Um, but yeah, if you find anything in there that's interesting or incorrect, or if you think there is a better way to do any of this, feel free to comment below. Um, if time permits, and there's something that you suggest that is more powerful, I guess, or is more insightful, yeah, I'll probably just add that to the next video when I do one of these on something related to pandas or data. Um, yeah, so that's it. Um, Thanks for listening, and I'll be doing hopefully all sorts of topics, and not just data. I'll be going over all my interests, so you'll be seeing a lot of different things in this channel. Um, You can follow me on Twitter at the Vishal Bakshi. So at the Vishal Bakshi. And then my website for now is vishalbakshi at github.io, where I also post a bunch of stuff, a bunch of blog posts and notebooks and stuff like that. Okay, thanks for spending your time with me asynchronously. Cheers.